This is SpaceTime Series 29, Episode 99, for broadcast on the 19th of August 2026. Coming up on SpaceTime, discovery of black hole stars at the cosmic dawn. Claims the red planet Mars might have had liquid water less than 1 billion years ago. And a new mission to extend the life of satellites in orbit. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers now think mysterious objects from the dawn of time, known as little red dots, may represent an entirely new type of cosmic phenomenon which they're calling black hole stars. Little red dots weren't even a thing until the Webb Space Telescope began providing us with observations of the early universe. As soon as astronomers saw them, they immediately started scratching their heads because they had no idea what these things could be. The best hypothesis suggests they're early, rapidly growing black holes wrapped in dense clouds of gas. Now, a new study reported in the journal Nature suggests these mysterious objects may help explain how monstrous billion solar mass black holes could have formed so soon after the Big Bang. Supermassive black holes, with masses millions to billions of times that of our Sun, lurk at the centers of most galaxies. But it takes time for them to grow. And so how really humongous ones could have formed during the very earliest period of the universe's existence is a real mystery. Beyond being cosmic points of no return, black holes also play a crucial role in determining the ultimate fate of galaxies, influencing their growth, evolution, and appearance. When they're actively accreting material, some of these cosmic leviathans turn into extraordinarily bright quasars, able to be seen across the other side of the universe. But their origins remain difficult to explain. Until now, astronomers have known very little about how these supermassive black holes could have formed. Also, it seems some quasars found in the early universe seem far too massive to exist. That's problematic as well. The study's lead author, Rowan Naidoo from the University of Hawaii, says explaining how billion solar mass quasars formed when the universe was so young has been challenging scientists for decades. Now, astronomers have never lacked imagination. Since the discovery of quasars, there's been no shortage of hypotheses to try and explain how these black holes grew so massive so quickly. Clearly, something spectacular must have happened in the early universe. Now, with NASA's Webb Space Telescope, Naidoo and colleagues can directly observe this epoch of the evolution of the universe. They can see which of the many scenarios speculated about actually occur. And they've now discovered a unique object from the cosmic dawn over 13 billion years ago that's offering them a clue about the formation of these unusually big supermassive black holes. The light which is reaching us now was emitted by this object when the universe was just 660 million years old. Naidoo says the spectre of light detected by Webb appears to be a cloak of gas feeding an early forming black hole. In addition to the characteristic features of a supermassive black hole, this object, which has been catalogued as MOM B8 star-1, exhibits properties normally associated with stars. These include a spectral jump called a Balmer break. That's an abrupt drop in a star or galaxy spectrum of light at the Balmer limit wavelength of approximately 364.5 nanometers. It happens when high-energy photons ionize hydrogen atoms from the second energy level, causing heavy absorption at shorter wavelengths. Now, in the case of MOM B8 star-1, the spectral jump is exceptionally strong, stronger even than those seen in star-forming galaxies, dust-free stellar populations, or the mysterious little red dots. Now, so far, the main challenge in understanding little red dots has been to separate the emission from the central object from that of the galaxy in which it resides. And MOM B8 star-1 resolves this issue for the first time by providing an unobstructed view of its core. Unlike other little red dots, MOM B8 star-1 appears to account for nearly all of the observed light, leaving little room for light from the host galaxy. So, instead of being reddened by dust, as was previously thought for little red dots when they were first discovered, this object, which they're now calling a black hole star, is enshrouded by gas which shifts its light emission towards the red end of the spectrum without blocking the view, similar to the Rayleigh scattering of light we see in Earth's atmosphere as sunsets turn red. Dew and colleagues monitored MOM B8 star-1 as a miniature supermassive black hole in the earliest phase of its evolution, enshrouded by extremely dense turbulent gas forming a dust-free envelope around it. Now, theoretical models have already predicted that early black holes embedded in these gas clouds can grow rapidly through what's known as super-Eddington accretion. MOM B8 star-1 lies close to a brighter galaxy, and models suggest these two objects will eventually merge, maybe 100 million years from now. By superimposing spectra from both cosmic objects, the authors found that the combined spectrum would closely resemble that of little red dots. If embedded in similar host galaxies, black hole stars like MOM B8 star-1 might well serve as the central engines of baby quasars. Considering the black hole star as a template for the black hole component of little red dots helps clarify many of the uncertainties about them. Now, back in March 2025, the discovery of MOM B8 star-1 was reported on the pre-press physics website archive.org, alongside what's probably another black hole star named the Cliff, a similar-looking source but roughly 2 to 3 billion years after the Big Bang. The simultaneous discovery of two such objects supports the hypothesis that these really are a new class of objects, which astronomers are calling black hole stars. And now that scientists have identified black hole stars, their spectra can serve as templates to guide new searches. And a new report in the astrophysical journal Letters has now identified a potential third black hole star candidate, but this one from a much later time period. And that suggests that these curious objects could also be found in much later cosmic times, though they are likely to be far less common then. This is SpaceTime. Still to come, claims Mars could have had liquid water on its surface less than 1 billion years ago, and the launch of a new mission to extend the life of satellites in orbit. All that and more still to come on SpaceTime. A new study claims the red planet Mars might have had liquid water flowing across its surface as recently as 757 million years ago. Now that's far more recent than the several billion years previously thought. The findings, reported in the journal Nature Astronomy, are based on a new analysis of mineral data gathered by China's Zhurong Mars rover. Until now, astronomers have assumed that Mars lost most of its water billions of years ago as the planet's core solidified and its protective magnetic field, which shielded the Martian atmosphere from the eroding effects of the solar wind, began to shut down. As the atmosphere degassed into space, the pressures and temperatures required to keep surface water liquid changed, resulting in water ice sublimating directly into a gas rather than turning liquid first. And so a once warm, wet world capable of supporting life was transformed into the freeze-dried desert we see today. Any liquid water would either have been locked away deep underground or lost into space. Now, previous estimates suggest this probably happened around 3 to 4 billion years ago. However, new research, led by Zhaicheng Liu from the University of Hong Kong, has discovered evidence of mineral crystals that could have formed in standing water on a patch of Martian ground far younger than expected. The findings are based on data samples collected by Zhurong on the vast plains of Utopia Planitia in the Martian Northern Hemisphere lowlands. Zhurong's cameras imaged bright flat rocks poking up through the sand, and later analysis suggests these rocks are rich in water-bearing minerals. Liu and colleagues examined the shapes of tiny crystals visible just beneath the rock's surface, some curling like cabbage leaves and others branching like Christmas trees. Using the rover's laser and infrared spectrometer, they determined that these shapes were produced by selenite, a large crystal form of gypsum that can only grow by crystallizing directly out of concentrated salty water. Now, based on the thickness of this mineral layer, the authors suggest that it would have had to have been formed in a body of liquid water somewhere between 6.25 and 25 metres deep, which pooled on the surface for a significant period of time. And based on the number of nearby impact craters, the authors were able to estimate the age of the ground to be somewhere around 757 million years old. Liu and colleagues think the water probably came from underground brine, melted and then upwelled towards the surface by volcanic heat. It was then on the surface and concentrated as it froze from the top down. Now, if these measurements are accurate, it suggests surface water could have persisted on Mars hundreds of millions to billions of years later than most models suggest. And since selenite crystals conceal tiny pockets of liquid they form in, they could potentially preserve a chemical snapshot of this ancient Martian environment. This is SpaceTime. Still to come, a new mission to extend the life of satellites in orbit. And you think they would have learnt their lesson from COVID, but scientists are now using artificial intelligence to design and build functioning viruses. All that and more still to come on SpaceTime. Northrop Grumman's latest mission to extend the life of orbiting spacecraft has successfully reached geostationary transfer orbit and is closing in on its first target telecommunication satellite. Launched aboard a SpaceX Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Space Force Base in Florida, the payload includes a Mission Robotic Vehicle, or MRV, spacecraft and 3 so-called Mission Extension Pods, or MEPs. Now, the Mission Robotic Vehicle is designed to intercept, rendezvous and grapple a target spacecraft using 2 3-metre-long robotic arms and then attach one of the mission extension pods to it. The MRV uses electric propulsion thrusters to manoeuvre in space, and it's equipped with advanced autonomous artificial intelligence systems that learn and evolve with each new mission. The mission extension pods are sort of, I guess you'd call them jetpacks, propulsion devices equipped with electric propulsion engines designed to provide up to an additional 8 years of operational life for a typical 2,000-kilogram spacecraft by replacing the satellite's own depleted fuel and propulsion systems. Once the pods are attached, the satellite's operators then take control through a self-contained C or Ku band telemetry and command system. The Mission Robotic Vehicle and its remaining mission extension pods then detach from the satellite and move to their next target spacecraft and repeat the procedure. Now, once each of these 3 pods are installed on a satellite, the Mission Robotic Vehicle will remain in geostationary transfer orbit, waiting for new pods to be flown up to it, which it can then use to service more satellites in an ongoing operation. Northrop Grumman says its Mission Robotic Vehicles can also relocate, inspect, repair and upgrade spacecraft in orbit. And it includes a passive refueling module, the first in-orbit refueling interface standard approved by the US Space Force. Now, all this isn't really that new. Northrop Grumman conducted 2 previous mission extension flights using an earlier generation of the MRVs, which it called the MEV, or Mission Extension Vehicle. However, these MEVs were more expensive spacecraft because they combined the role of the Mission Robotic Vehicle and the Mission Extension Pods. The first Mission Extension Vehicle flight was the MEV-1 back in 2019, which successfully rendezvoused with the Intelsat IS-901 spacecraft and remained docked to the vehicle for 5 years before finally detaching and moving on to another satellite in May last year. It was then followed by the MEV-2 in 2020, which docked to the Intelsat IS-1002 spacecraft and is still attached today. This report from Northrop Grumman.
High above Earth, there are thousands of satellites that circle the planet. But once satellites are launched, if something goes wrong, how are they repaired? What if they're running low on fuel? For decades, otherwise healthy satellites were retired to the depths of space. Until now, the next generation of robotics in space is here. This revolutionary system will change the satellite industry forever. Building on our pioneering Mission Extension Vehicle, the Mission Robotic Vehicle represents a groundbreaking advancement, a spacecraft capable of repairing, relocating, and even building in Earth's orbit. Using the smaller Mission Extension Pods, this technology acts as a jetpack, adding years of life to vital satellites. The spacecraft start their journey to their first rescue mission. 22,000 miles above the Earth, the MRV and MEP rendezvous. Accurate to the centimeter, the fully articulating robotic arms autonomously secure and stow the extension pod. After traveling thousands of miles, it approaches the satellite that has run low on fuel. Moving thousands of miles per hour, the spacecraft is now within just inches of finishing its mission. Extending its arm and attaching the extension pod perfectly to the satellite. Adding 6 more years of life to a dying satellite, the MRV fires its thrusters ready for its next mission. Thousands of miles above the Earth, a customer's satellite with a partially deployed solar array needs help. As we approach the satellite, the mission robotic vehicle inspects the issue and operators on Earth assess the situation. Using its robotic arm, it carefully dislodges the array, using its onboard camera to inspect for any damage. After another successful mission, we travel on to support even more satellites for years to come.
This latest mission uses the newer, more flexible Mission Robotic Vehicles, or MRVs, together with 3 mission extension pods. It'll see 2 of the pods hired out to Intelsat for 2 more of its telecommunications satellites, while the 3rd will be attached to the Optus D3 satellite as part of the Singtel company's Project Aurora. This mission is an extremely rare bit of good news for Optus. The embattled telecommunications company faces major controversies which have severely trashed its brand reputation, including poor customer services with phone help waiting times of over an hour, federal court legal action over a fatal emergency call outage, massive consumer penalties for predatory sales tactics targeting vulnerable people, and a history of data breaches. Australia's telecommunications industry ombudsman highlighted how Optus repeatedly failed to address customer complaints efficiently. Instead of dealing with problems, Optus kept customers trapped in endless bureaucratic loops when trying to seek service fixes or financial compensation for major outages. Right now, the Australian Communications and Media Authority, ACMA, is suing Optus in the federal court over the infamous September 2025 network outage, which caused hundreds of emergency calls to fail, alleging over 1,000 breaches of legal obligations. The 14-hour Optus outage left 75% of emergency 000 calls unsuccessful, with 605 failed attempts, and those failures have been linked to at least 2 deaths. And none of this is new. ACMA previously fined Optus $12 million over a separate November 2023 outage that blocked emergency access for over 2,100 customers. And previously, the federal court ordered Optus to pay a $100 million penalty following an ACCC investigation into appalling sales misconduct between 2019 and 2023. Optus staff had systematically pressured hundreds of financially vulnerable customers, pensioners, people with disabilities and individuals with limited English proficiency into buying expensive phone plans they could neither afford nor use, even in areas lacking Optus network coverage. Let's face it, that's simply theft. Then there was the massive cyber attack in September 2022, which compromised the personal identification details, including passports, driver's licenses and Medicare numbers, for millions of current and former customers. The Office of the Australian Information Commissioner has initiated civil penalty proceedings against Optus regarding this severe security and privacy failure. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. Lung cancer is the leading cause of cancer-related deaths in the United States, with 229,410 new cases and nearly 125,000 deaths projected for this year alone. Now researchers at Tel Aviv University may have found a faster and more inexpensive way to detect cancer, a simple $60 blood test by reading the tumour's unique chemical fingerprint using light, no DNA sequencing required. In a study of 103 participants, the test achieved 93.1% accuracy among stage 2 to 4 patients. Nearly half of all US lung cancer cases are diagnosed only after the cancer's already spread, so a $60 test that could catch it early could save thousands of lives every year. A new study has found that having European ancestry is linked to a greater risk of developing colorectal cancer, although differences in health, behaviour and family history also have a big impact on risk. The study, reported in the Journal of the American Medical Association, looked at data from over 300,000 people. The authors also found that having American and mixed Latino and East Asian ancestry was linked to earlier diagnosis and higher age-related risk. As if China's genetically engineered COVID-19 virus escape from the Wuhan Institute of Virology wasn't a big enough warning, Scientists have now used artificial intelligence to design and build bacteriophages, functioning viruses that infect bacteria. The findings, reported in the journal Science, are raising important new biosecurity and biosafety concerns. The researchers were able to design viruses to kill 2 strains of bacteria that were resistant to other similar viruses, suggesting this could be a way to design antibacterial therapies. But they admit the ability to design and create functional AI-generated genomes introduces important biosafety and biosecurity concerns and underscores the need for expert oversight and robust safeguards throughout the design process. The World Health Organization says more than 7.1 million people have been killed by the COVID-19 coronavirus since it was first detected among 3 scientists working at China's Wuhan Institute of Virology back in September 2019. Between 17,200 and 22,000 deaths were caused by the COVID-19 virus in Australia, although broader excess mortality modelling, which accounts for indirect systematic strains and unrecorded infections, estimates the total pandemic-related death toll is more likely to be around 31,000. And the Lancet Medical Journal estimates the true global death toll is likely to be somewhere around 18 million, with over 750 million people confirmed to have caught the disease at some stage. A new study has shown that school kids who start using social media earlier in adolescence often end up performing worse in standardized tests later. The findings, reported in the journal Nature Human Behavior, are based on a survey of 5,227 Italian school kids about their social media use and then compared this with test scores in Italian, English and maths at ages 13 to 16. The authors found that kids who delayed opening social media accounts until they were 14 to 15 years old consistently scored the highest in Italian and maths tests, followed by those who started on socials aged 13 and 14, then those aged 12 and 13, and then those aged 11 and 12. The authors say the gap between children who started on social media aged 11 and 12, those who delayed their use until 14 and 15, is roughly equivalent to 6 months of schooling, while even starting at age 13 and 14 could leave a gap equivalent to roughly 3 months of school. Google's new Pixel 11 smartphone's just been released. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.life.
Google is launching its new suite of phones, the 2026 phones. This includes its Fold, which is basically the phone that turns into a mini tablet, and also a new watch. So what we have here is major camera upgrades, promising enhanced durability and sophisticated designs. They do look pretty cool. It's got the Google Tensor G6 chip. Now, this chip has never been as fast as the chips from Qualcomm or Apple, but Google is saying it's the fastest, most powerful chip to date, and it runs the Gemini Nano model, which is the smallest version of onboard AI. And onboard AI is, of course, something that we're going to take a lot more seriously in the years to come, because we'd love to have today's level of AI, but running offline. And that's still to come, but offline models do work, and they're pretty good. And this, of course, is designed for Gemini Intelligence to deliver what they call time-saving personal help. And that's where you have the magic cue that you're ringing your airline, and it pops up the information about the ticket and the place you're going, or you're ringing a restaurant, and it gives you your booking details. Now, the Pro 11 Fold, they're saying it is a thinner and lighter design, but it's still thicker than Samsung's design, which, of course, when you shut it, it does feel like a single phone. I mean, this is 10.1 millimeters, whereas Samsung is unfolded. It's 4 something millimeters, but it's about 8 millimeters. So there's a little bit of a difference.
You've got that big backpack on the rear where the camera is, don't you?
Well, yeah, that's the camera bar. They are putting in upgraded cameras and also, faster charging speeds on the Fold, which is good. And with the watch, that is the Pixel Watch 5. It's a 3,000 nit display, so nice and bright in the summer. It's a domed Actua 360 display, which is their way of describing how good the screen is. They've got 11 new glanceable complication styles, 2 new watch faces, up to 30 hours of life. They're also talking about industry-leading repairable architecture. This is something that normally these small devices are not so easy to repair. But one of the things that the new Pixels have is a light on the back. It's called Highlight. So this is a little light that looks like it could be the flash, but it's not. It glows in different styles. If an important call needs your attention, for example, Android phones used to have little notification lights that glowed with different colors to let you know there was a message or somebody calling. But this is on the back, so you can put the phone down. It's a hardware and software notification tool, and it's only on the Pixel 11 Pro line. So this little LED indicator glows in specific colors when the phone is placed face down, letting you identify incoming calls from favorite contacts. We'll see active prompts like Gemini, and it's just a way of letting you glance at your phone, especially if you put the phone down so you're not being otherwise bombarded by notifications or, attracted to the phone lighting up. And it can just tell you these little things that let you know if someone important is calling. You can assign different colors to different people, for example. So that's a little quality of life feature that resurrects the notification light that a lot of phones used to have.
How do they compare on price? I mean, the Pixel 11 can be up to, $2,800?
Well, it obviously depends which model that you get. Now, the Pixel 11 starts at $1,499. The Pixel 11 Pro starts at $1,849. And the Pro XL, 11 Pro XL, is $2,099. So the age of cheap phones, when you're talking flagship, is gone. Yeah. Now, all three of the majors, Apple, Samsung, and Google, do have upper mid-range phones available under the $1,000 mark. You don't have to have the absolute latest flagships with the very fastest processors to enjoy email, surfing, social media, gaming, all the camera capabilities and all the AI capabilities you want. Obviously, if you're a young person or a fashion person or an influencer, you want to have the latest and greatest. There are plenty of people, they just get these phones on a plan. They're not so expensive. I mean, even a phone that is $3,600, for example, if you get the top of the line Samsung Fold or the upcoming iPhone Fold, I mean, it's probably going to be in Australian dollars, $3,600. But if you go on a 36-month plan, that's $100 a month. Yes, you still need to have a phone plan to go on top of that, which will be usually at least $50. So that's like $150 a month. But in the modern world, that's not unachievable or unaffordable. It allows you to break that larger purchase down.
That's Alex Zaharov-Reuter from TechAdvice.life, and this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.